live on a relatively small planet, the surface of which is 2/3 water. In an eternal cycle, moisture from evaporation rises into the air, clouds form, condensation takes place. Snow and rain fall upon the earth to be distributed by river systems throughout the land, rivers which in turn flow back into the sea, so that the cycle can begin again. Historically, growth and economic development have always been dependent on ample supplies of fresh water. But today, advancing technology and expanding industry on a broad international scale have achieved a rate never before equaled. At the same time, however, management of water resources has not kept pace. It has become more and more apparent that one of the great problems facing the world is water and its proper management, its collection, its distribution, its disposal, and the interrelations that tie these features together, such as flood control, pollution control, conservation, recreation, irrigation, hydropower development, and reuse. To meet the critically urgent needs as they exist today and in the foreseeable future requires more than just ample supplies of fresh water. It takes the total planning of overall water management. The water problem has traditionally been considered a local or regional problem, but it is not local or regional. It is a continental problem, which requires a solution on a scale that is also continental. This motion picture is about the North American Water and Power Alliance, NAWAPA. NAWAPA has been conceived as one possible solution to help the collection and distribution segments of the overall continental water management problem. In terms of water, power, flood control, transportation, and recreational facilities, more than 33 of the states would directly benefit. In Canada, 7 provinces and 1 territory would directly benefit, as would regions in northern Mexico. On our continent, it is estimated that in less than 40 years, water usage for municipal, industrial, and agricultural requirements will more than double the figures for the year 1960. Growing needs are such that someday we may be able to meet those needs only by utilizing every means to procure fresh water. Where there are no resources of fresh water to develop, desalination is the only way. Therefore, continuing emphasis on research and development of desalination is important. It is, however, very costly to pump water from sea level inland. In this regard, it has been authoritatively stated that if the Mediterranean Sea were by some miracle turned into fresh water, the cost of transporting that water into the Sahara Desert would still make such a project prohibitively expensive. On the other hand, control of flowing rivers can be made to yield electrical power, which makes it cost practical to lift water to sufficient altitude so that it can be distributed by gravity flow. Development of the Nawapa Concept by the Ralph M. Parsons Company has been based on the company's long experience in developing water projects throughout the world to meet the great common need. It is a need that on our continent surely requires foresight and planning now for the full constructive use of water resources. For example, some areas are at the mercy of too much water, while others suffer from lack of sufficient supplies. And in other regions still, the priceless resource pours unused and wasted into the sea. Past and present water plans, and those currently under proposal, are stopgap regional or local schemes for taking water from one river basin with a current surplus and transferring it to a particular area suffering from a critical shortage. Desert areas of North America that can be brought to life with supplies of water at reasonable cost are well known. But actually, we are facing a water shortage in large areas of Canada and at least 25 of our 50 states and in Mexico. In cities with a population of 25,000 and over, speaking in the present and not looking forward to normal growth, 1 out of 5 water utilities is deficient in supply. 1 out of 3 show deficiency in ground storage, and more than half require distribution system improvements. In the Great Lakes area, Lakes Huron and Michigan are at their lowest level in 104 years. Canada has protested withdrawal of water by the city of Chicago, pointing to low water levels and impairment of navigation. The mayor of a Canadian city proclaimed, "We are a disaster area." Even at Niagara, power generation is restricted because of decreasing water flow. The shortage of water supplies is not a local problem. It is a continental problem. At a first or casual glance, the size of the North American Water and Power Alliance concept may seem unrealistic or fanciful. Closer and more thoughtful analysis of the concept, however, reveals it is not only imaginative, but that from an engineering viewpoint, it is feasible. From an economic viewpoint, it is realistic. In overall planning by the Ralph M. Parsons Company, the Nawapa Concept takes advantage of the geographical and climatological factors of our continent. Only water which is surplus now or in the foreseeable future will be used. In return for water, the supplying areas would be compensated in power or in some other tangible source of revenue. The primary sources of water collection are in southeastern Alaska, the Yukon Territory, and British Columbia. In the Nawapa Concept, only about 20% of the surplus water of the collection area will be used. 40% or more of the surplus could be made available. A series of dams and power stations will provide the power for pumping the water up to the Rocky Mountain Trench at 3,000 feet. The trench is a natural geological defile some 900 miles long, from 5 to 15 miles wide. About 500 miles of the trench would be utilized as the reservoir site. From the trench reservoir, water is pump lifted to the Sawtooth Reservoir. From here, water flows southward by gravity via lined canals and tunnels throughout the system, passing the Sawtooth Mountain Barrier through a tunnel 80 feet in diameter and 50 miles in length. Continuing its gravity flow, the water will help meet the needs of the western part of the continent. Water for irrigation, power, recreational facilities, and other uses would flow for distribution to eastern Oregon, to Utah, to Nevada, California, Arizona, and northern Mexico. A diversion aqueduct in Utah would provide good quality water in bulk to those areas currently using Colorado River water with its excessive mineral content. That good water could, by leaching process, eventually recover thousands of acres of valuable farmlands, which have become degraded by the Colorado's excessive mineral content. On the east slope of the Rocky Mountains, water would be pumped by way of the Canadian and Purgatory rivers and distributed east of the Continental Divide. This water would be drawn upon by New Mexico, Texas, Colorado, Kansas, Nebraska, and Oklahoma. The Peace River Reservoir outflow and diverted flows from several streams on the east slope of the Rocky Mountains would supply the Canadian Great Lakes Canal. In excess of 40 million acre-feet per year would reach Lake Superior and provide for irrigation and other water demands of Alberta, Saskatchewan, Manitoba, and Western Ontario. This important part of the system would also yield considerable power. The Canadian Great Lakes Canal would alleviate falling levels and pollution of the Great Lakes, as well as augmenting the power potential of the Niagara and St. Lawrence rivers. Normal water levels then could also fortify water supplies in troubled eastern areas. The Nawapa Concept includes a seaway between Lake Winnipeg and Hudson Bay via the Nelson River. Another seaway would connect Georgian Bay with James Bay. A barge canal would connect the ore fields of Labrador and Quebec with the Great Lakes.